Have you ever wondered how a one-way clutch operates? A marvel of mechanical engineering, the one-way clutch, also known as a freewheel clutch, is a device that allows rotation in one direction while preventing it in the opposite direction. But how does it achieve this unique function? Let's delve into the intricacies of this device's operation. Firstly, we need to understand the basic components of a one-way clutch. The clutch comprises an outer race, an inner race, needle rollers, and springs. The outer race is essentially the shell of the clutch, while the inner race is a cylindrical component that fits inside the outer race. The needle rollers, which are small cylindrical components, are positioned between the outer and inner races. The springs are used to push the needle rollers into grooves or pockets in the outer race and the inner race. Now, let's get into the nitty-gritty of how a one-way clutch works. It all boils down to two main processes: engagement and disengagement. Engagement, or forward rotation, happens when torque is applied in the direction the clutch is designed to transmit power. The needle rollers, forced by the springs, engage with the grooves in both the outer race and the inner race. This creates a solid connection between the outer and inner races, allowing the torque to be transmitted from the outer race to the inner race, and ultimately to the connected shaft or component. Disengagement, or reverse rotation, occurs when torque is applied in the direction opposite to the desired direction of rotation. The forces generated during the reverse rotation push the needle rollers outward. This disengages the rollers from the grooves in the outer race and the inner race, preventing the transmission of torque in the reverse direction. The inner race and the connected shaft or component remain stationary during reverse rotation. In essence, a one-way clutch is a cleverly engineered device that allows rotation in one direction and blocks it in the opposite direction. It achieves this by engaging and disengaging its needle rollers with the grooves in the outer and inner races, depending on the direction in which torque is applied. This seemingly simple but effective mechanism is what enables the one-way clutch to control the direction of rotation and the transmission of power, making it an indispensable component in various mechanical systems.